Muito bom dia, pessoal. Sejam todos bem-vindos a mais uma transmissão aqui no canal Will PTV. Hoje estou trazendo para vocês a parte 2, a segunda tentativa para o lançamento aí do Alpha, né, da FireFly, aí com a missão FLTA006, Message in a Booster, lá em Vandenberg, na Califórnia. Lançamento previsto para acontecer no mesmo horário de ontem, o primeiro horário de ontem, às 10h37 da manhã, pelo horário de Brasília. Nosso tempo de duração desta missão será de 12 minutos e 42 segundos. Hoje com uma carga aí da Lockheed Martin LM400, Skylight. Certo? Então, dentro de instantes, estaremos em contato com o Vandenberg mais uma vez, para a gente poder curtir, então, este lançamento do Alpha. O UPTV sempre mostrando tudo que acontece ao redor do mundo e também na Estação Espacial Internacional. Lembrando, caminhada espacial no dia 1º. Hoje de manhã tivemos, então, aí o lançamento do Vega C, feito e realizado com sucesso, aqui na Guiana Francesa, levando então o satélite Biomass da ESA. Hoje, né, então vamos ver se vai tudo certinho aí com o Alpha, né? Hoje, essa semana, então esses 2 dias aí, festival de lançamento, né? Tivemos aí, ó, missão Starlink no dia 27, tivemos 2 missões Starlink no dia 28. Tivemos também hoje aí tivemos um lançamento chinês ontem também, o Long Mark 5D. Hoje também tivemos aí o lançamento do Vega C e agora o Alpha, né? Então tivemos só nesses 3 dias aí, né? Tivemos 1, 2, 3, 4, 5 lançamentos, né? 5 lançamentos aí em 3 dias, né? Aí eu estou aguardando também a confirmação de um lançamento russo. Aí seria o 6, né? Que foi lançado ontem, né? Aí pelo Angara 2, né? Então são Cosmos. Estou aguardando a confirmação dele, que até agora a agência russa não confirmou ainda, tá? Vamos acompanhar então aí a FireFly. Não se esqueça do like e de se inscrever no canal. Hoje, então, 29 de abril de 2025, pelo horário de Brasília, agora são 10 horas e 1 minuto.
Welcome back this morning to the broadcast of FireFly Aerospace's Alpha Flight 6 mission. You can see the rocket out there, but there is a fair amount of Vandenberg marine layer happening, so we're going to be bringing you all of the different views that we can, hoping this clears up a little bit, currently about 35 minutes before launch. My name is John Galloway with NASASpaceflight.com, providing some live stream media services for FireFly this morning. And joining me from FireFly Aerospace itself is Morgan Fiane, who is a composites structure responsible engineer at FireFly. Good morning, Morgan.
Morning, John. It's good to be back.
Welcome back.
Yeah, thank you. I am ready to see this thing go today.
All right. So we're seeing it. I mean, we've got some rocket views, some of those closer in cameras, but the marine layer out of Vandenberg is causing us a little bit of visibility problems this morning. We are going to start off the broadcast by talking about, I guess, the elephant in the room, the scrub yesterday. Let's talk through a little bit about what happened there at the end of the window that caused Alpha not to launch in the first attempt.
Yeah, so what ultimately caused the scrub yesterday was due to a ground support software issue and a helium pumps. So we have several kind of auto kind of checks and balances, sensors that monitor the ground support equipment and all that.
Right.
And they will trigger an abort if it reads something that is out of nominal range.
Okay.
So, yeah, we had an auto abort right at the end of our 52-minute launch window yesterday. So we just needed to spend some time ensuring that everything was healthy before we tried again today.
Gotcha. So to bring that down to musical terms, one of the sensors, or a few sensors on the rocket, were sending an SOS out to the world, or at least mission control yesterday. That's how it's designed. So many different sensors checking in, things checking against each other. If something's out of family, sometimes you have time to recycle that. We saw that happen a couple times earlier in the count yesterday, but with that hold, the auto abort right there at the end of the count, just not enough time to recycle and troubleshoot. So the teams took overnight to go through that and make sure everything was good for launch today.
That's exactly right. So last night the team updated the software, and they also replaced the helium pumps that were causing some issues. And so we're feeling good right now.
All right. That was a call out we heard specifically in LCC yesterday. The fluids team was not happy with the helium. It sounds like there was some hardware replacements there in that GSE, but GSE is definitely a thing when it comes to rockets.
Oh, yeah. It's not just the rocket. There's a bunch of other departments and things that come together to make things work.
All right. But we are back for another attempt here. Now that we've got the elephant in the room out of the way, let's talk about the unicorn in the room. If you look at the top of the camera there are some balloons in front of the FireFly logo.
Yes.
What's going on?
Yeah, it's actually our LD's birthday, Megan Roth. So yeah, we've got a couple birthday decorations in there just to give some well wishes.
To spice up mission control a little bit.
Yeah.
All right. So, folks, again, if you're joining us, we are counting down just under 33 minutes away from the launch attempt of FireFly's Alpha mission here this morning. It's great to hear, Morgan, that the rocket and payload are healthy here, and we are ticking down towards another launch attempt. Currently, just over 32 minutes away from launch. This is going to be Flight 6 of FireFly's Alpha rocket, with the launch scheduled, or actually, let's say a window and launch, both scheduled to start at 6:37 a.m. Pacific time here this morning. Now, remember, we have a 52-minute launch window. If you were here with us yesterday, you saw us use that window to go through those holds and troubleshooting, but we've got the same thing again this morning, extending all the way up to 7:29 a.m. Pacific time. Zooming in on Vandenberg Space Force Base over here, out on the west coast, the rocket's going to be launching from Slick 2, SLC2. You say slick because then you sound cool. That's how it works.
Space stuff.
At least I hope it sounds cool. Out that way, let's do this. What are we flying on the mission here? We've got a payload, commercial customer, Lockheed Martin. Let's talk a little bit about what's on top of the booster.
Sure, yeah. So today we're launching Lockheed Martin's LM-400 satellite. LM-400 is a tech demo that proves out this new kind of multi-mission satellite bus. It's the second mission that FireFly is launching for Lockheed.
Right.
And it's actually the first mission we're launching as a part of our multi-launch agreement with them. So that's a huge multi-launch, like 5-year agreement that we can launch up to 25 alphas for them in that 5-year span.
Up to 25 different missions.
Up to 25 different missions.
It's good to have a catalog there, huh?
Yeah, it's nice. It's nice to have that backlog. And this payload is actually the largest that FireFly has ever launched to date.
Right.
It's about the size of a fridge.
I think we mentioned that yesterday. Like, it's about the size of a fridge. I'm trying to think of like other things that are the size of a fridge, but I'm drawing a blank.
Fridges are pretty solid, one-to-one comparison.
I don't know what a fridge is.
There's some pictures. They might show up, they might not. But you can actually see people standing next to the payload, so you can get a
sort of see the
sense
scale.
of scale.
Yeah. Help us out. Folks, if you're watching back at home, what else is about the size of a refrigerator that we could use? We've got chat over here on the monitor. We will be reading through some of those this morning. We might have some time for some questions, so if you've got questions, make sure you tag us. Let's get going with the weather update here. Besides the marine layer, which I hope is clearing up a little bit, how's the weather looking?
Yeah, so it is looking foggy out there. Right now the team is proceeding with launch down count procedures. But they are monitoring their weather. So there are 2 conditions for weather that we have to make sure we stay below for the structure and for a couple other things. There's one on the ground level, which I think is like 23 or so miles per hour. Like
the wind limits, right?
The wind limits. And then there's an upper level wind limit that's a little over 55 miles per hour.
57, I think.
57, yeah. So we have to make sure we stay below those. So the range has sent up a weather balloon, and we're monitoring the weather this morning, showing the upper level winds are trending on the high side for structural limits.
Right.
But we are seeing that start to go down a little bit.
Gotcha. So enough confidence, enough margin there in the current weather outlook that the team continues the count, but we're very closely watching those upper level wind limits. They're right there near the line, hopefully trending better as opposed to worse. But we are continuing to count down, now officially under 30 minutes from the launch. Let's talk about what the team has accomplished a little bit to get to today. And if you were with us on the broadcast yesterday, we talked through some of this, but every time we do a show, there are new people here, so let's talk through the preparations for launch that have already occurred.
Yeah, so in the last 3 days, we've integrated the satellite to the PAF. So we've kind of clamshelled it in the fairings as well. We've completed final... what?
I like the outline of the rocket there. You can see that camera's about 300 feet away.
Yeah.
And the rocket's kind of there, but we have the little X-ray vision outline we can show you on occasion.
Yeah.
Sorry to interrupt, Morgan.
No,
there's a satellite on a payload.
Yeah, there's that picture. Yeah, so you can kind of see the sense of scale. It is about the size of a fridge. It's pretty big for what we've flown before.
Right.
But yeah, in the past 3 days, you've seen them, they've made it to the PAF. That's that kind of conical shape in the picture. It's our payload attachment fitting.
That looks like carbon fiber.
It is carbon fiber.
It is carbon fiber.
Yeah,
that's a nice structure.
Thank you. So yeah, we've bolted that on. We've completed final payload checkouts, made sure everything's fine. We've encapsulated that payload in the fairing, like you can see there. There you go. There's like clamshell picture.
Clamshelling, yep.
Yeah, there you go. And then we'll transfer that whole payload fairing stack with the integrated payload to the pad, and we'll mate it to a horizontal alpha, and then we'll raise her up and get ready to go.
Love the reflection shots once again. Anytime there's a puddle of water snapping a photo, if you've followed along on social media, there were some fantastic shots being put out there. But there's the payload being protected by the fairing, rolling out to the complex. And there's the fog again.
It is Vandy.
It is Vandy. Yesterday was such a beautiful day, and today here, maybe everything is in balance in the universe. Like less views of the rocket with the marine layer there, but hopefully better weather. Let's get that camera a little closer so we can see what's going on. All right, so that was sort of how to get the payload from the building over to the pad. Let's talk about the pad preparations that need to occur this morning early to get the teams ready for launch.
Yeah, so after we get the payload out of the PPF and onto Alpha, there's a lot of things that happen overnight. So in the last 8 hours, we've configured the pad for flight. We've cleared the pads. There's no personnel out there right now. At T-minus 4 hours, we actually start fueling the rocket, and that lasts for several hours. We're still fueling.
Right.
And in total, it's 3,000 individual manual steps that you're checking through on like a list of procedures.
Like people actually doing steps.
People doing steps,
right.
Yeah. Technicians out there, people on console, like making sure everything's healthy. And it's accompanied by about 50 automation sequences that kind of assist the humans in, checking the health of the rocket.
Right. And that's where some of these sensors sort of come in, like numbers that are coming through. Maybe there's 1 or 2 or 3 sensors all looking at the same thing, making sure they agree, so that throughout the entire process this morning, watching those sensors all around the pad, the GSE, making sure that everything's healthy for a launch. But the clock continues to count right now. We always get this question. I always lead into this question by saying we always get this question. Can you see the launch this morning? And it's really going to depend on where you're watching from. So let's talk through that really quickly. But while we do that, over there in the chat, tell us where you're watching from. You can watch from anywhere in the world here on the live stream. But if you are over on the west coast of the United States, you might be able to step out your front door and see the launch. Over there in Los Angeles, be looking to the west, out to the water. Southbound trajectory this morning, so it should go past you over to the west. San Diego might have a good view as well, all the way over to Las Vegas, into the desert states. We'll get all the way over to Albuquerque, I think. Yep, there's Albuquerque and Phoenix. Seattle may be a stretch because the rocket is going to be going away from you to the south. But hey, if you're here on the live stream, come on over, listen to the rocket take off, watch it on your phone. Maybe take your phone outside with you when you go to see it. But if you find a view of the rocket, snap a picture. Use your phone, use whatever camera you have available. And if you want, post it on social media. If you tag us at FireFly_space over there on X, we love to see it. We love to see how people see the rockets in the real world. So, let's see here. We've got that. We've talked through how you can view the mission. I can't read where you're watching from right now because there's too many folks, but I know that you're watching from all over the world. So let's continue on talking about our payload here this morning. A little bit more details about the LM400 payload. Lockheed Martin.
Lockheed Martin, yes. So the LM400 payload is their new multi-mission satellite.
Right.
It's big kind of bus. It's, it can serve anywhere from military to civil to commercial markets. So it's got a broad range of potential customers.
Right.
And the whole point of LM400 is its capabilities for things like remote sensing, communications, imaging, radar use cases, all that kind of stuff. So it's really primarily like a communications and data collecting satellite.
Right.
Yeah.
When we say bus, it's sort of here is the structure of the satellite. It's got all the satellite things that you need for a satellite to live, power generation, thrusters, attitude control, that sort of stuff. But the payloads you can put on the satellite itself, different sensors, communication packages, all of those different things are what you're talking about when it can be customized for different uses or missions or whatever. So here, flying LM400, making sure the satellite itself is good to go so that they can come up with those different packages, I guess you could say, to serve different missions.
Yeah, I'm sure there's some level of customizability for each customer.
All right. So a great way to hear more about this is to take it straight back to Lockheed Martin. Let's listen into a quick video from them directly.
Hey there, I'm Robert Lightfoot, president of
Vocês que estão chegando aí na transmissão, estamos acompanhando então a segunda parte, ou seja, a nova tentativa para o lançamento aí do Alpha, a missão 006, Message in a Boosted, com a Lockheed Martin e com o satélite LM400. O lançamento então por enquanto está mantido pelo mesmo horário de ontem, primeiro horário de ontem, às 10h37 da manhã. Mas como vocês podem perceber, o tempo está meio nublado, né? Um pouco de neblina também lá no local da Califórnia. Mas por enquanto nada disso está afetando o veículo, o lançamento. Vamos lá continuar então acompanhando a transmissão. E o PTV sempre mostrando tudo o que acontece ao redor do mundo e na Estação Espacial Internacional. E hoje, mais uma vez, estão com os nossos amigos parceiros, né? Aí a NASA Space Flight.
Checking in with chat during the video there, I saw some love for the fancy backlit logo in the background there from Lockheed Martin. Always good to get information directly from the source. Coming up in just a couple minutes here on the Ready Report, the T-minus roughly 20-minute Ready Report, where we'll hear all the different stations check in. The mission name real quick, though, from Lockheed Martin, message in a booster.
Yes.
Eh?
What do you mean,
Well,
we're inspired by a specific song. I don't know if copyright's a thing for that, so I'm not going to say it.
I'm not humming it.
I'm not going to hum it, but yes, Mission in a Booster is inspired by LM400 as a communications satellite.
Gotcha. Makes good sense. All right. So as we get about a minute away from this ready poll, let's talk through what we expect to hear. We're going to have all the icons come up on the screen. Hopefully they all go green. Who are we hearing from there when that happens?
Yeah, so the LC, the launch conductor, will ask for a go or no-go, and that's everyone in Mission Control's opportunity to continue monitoring the health of their systems and make sure that they say...
Count will be in 1 minute. I repeat, readiness report for terminal count will be in 1 minute.
All right.
There you go. 1 minute.
Count.
You have 1 minute
to explain it. But yeah, so each of the people that you see in Mission Control are looking at the health of their systems.
Has transitioned to internal power and is configured for launch.
All right.
Really trying not to talk over
Yeah,
them.
we really don't want to talk over them there.
Yeah, so Justin Fullen, our LC, will ask for a go or no-go from each of these guys in the room.
Right.
And they're making sure that their systems are healthy, and so over 20-plus subsystem alpha leads, payload lead, range operations lead. It's not just FireFly, it's also the range.
Right.
And their
And the customer.
And the customer.
LCC gate has been met.
Here we go.
Nice.
Acknowledged. This is the launch conductor on the countdown net with a ready report for terminal count. RC. Go. FSW.
Go.
GSW.
Go.
GNC.
Go.
Prop 1.
Go.
Fluids 1.
Go.
Structures.
Go.
AVI.
Go.
FTS.
Go.
GC.
Go.
VC.
Go.
PMM.
Go.
LWO.
Go.
FISPO.
Go.
MIFCO.
Go.
OSM. ROC.
Go.
MA.
Go.
CE.
Go.
LD.
LD is go.
LDA.
LDA, clear to launch.
We are go for Flight 6.
There you go, folks. That was just right down the line, quick, fast, and in a hurry. Every station reporting in nice and clearly that we are go for launch.
Might have given a fist pump back here. No one will see it. It's okay.
Luckily, our cams were off. We were over here cheering as all the green lights turned on. So coming up on T-minus 19 minutes, that is exactly what you want to hear during the poll. All of the lights going green. Now things are going to start happening pretty quickly. So let's talk a little bit about let's talk more about the parts of Alpha. Unfortunately, can't see them on the screen right now, but I think we have some movie magic to share with you. What makes an Alpha?
Yeah, so Alpha is a two-stage Kerolox rocket. And what that is it's RP1, which is basically just kerosene, and liquid oxygen, which is a cryogenic fuel.
Right.
So this rocket can take about 1,000 kilograms to LEO, which is low Earth orbit, and it is the largest vehicle in its small lift class.
Right.
So we're still a small vehicle, but we are the largest in kind of that
small
category.
vehicle class. Right.
Yeah, and we can do this for two reasons. One of them is our engines. So on the screen there, you can see the stage 1 engines are called Reavers. There are 4 of them on stage 1. You could maybe see some TPC wiggles here on the cameras. So there's 4 Reavers on stage 1, and there's 1 Lightning engine on stage 2. Now, these are all designed, built, and tested in-house up at Briggs, our manufacturing and test facility.
Right. It's like 30 minutes up the road here.
Yeah, it's like a half hour up the road. And these are all actually tap-off cycle engines, which are kind of a more simple cycle of engine compared to some other stuff you might find out there.
Right.
But that's on purpose. The point of making our engines a tap-off cycle and to target them to be as simple as possible is to target better reliability, manufacturability,
right.
Ease of putting this thing together.
We talked through that yesterday, not trying to push the limits of engineering or physics or anything like that. You just want something that's nice, repeatable, easy to manufacture, lower cost. It's just going to do its job.
Yeah, something that will ideally work every single time.
Excellent.
And then part 2 of why Alpha can be Alpha is my favorite thing to talk about is the carbon fiber composites that make up the structure of Alpha.
Like the main body.
The main body, yeah, like kind of the big skeletal structure of the rocket. So these carbon fiber composites are super strong, they're super lightweight, so you can lift more payload at a lower cost because you're not sacrificing all this extra weight. I think on average for our trade, we're about 30 to 40% lighter using carbon than if we were to use metal.
No kidding.
Yeah.
And on the screen there, you can see some of the new equipment y'all have that are enabling that carbon fiber layup. Can I say that? Is that the right way to say it?
Yeah.
Do I sound cool if I say it that way?
Yes, you do sound cool.
Nice. But that's the AFP, the automated fiber placement machine.
Yes, that is true. So we bought the AFP fairly recently. That's a lot of what I've been doing is helping online that AFP program for structures. AFP stands for Automated Fiber Placement Machine. AFPM, yeah, sorry, cheated a little bit. But yeah, what's cool about Flight 6 for Alpha specifically is that we've started to incorporate AFP structures on the rocket. So our stage 2 LOX tank, you can actually see it right there.
You can actually see it right there.
Yeah, that kind of white painted cylindrical section, that is our very first AFP flight tank that we have ever made at FireFly. So very exciting stuff.
And actually flying today, like not, we've made a bunch of test tanks and we have a pile of test tanks that is integrated on the top of the vehicle, ready to go to space.
It is right there, yeah. So AFP is awesome. I can nerd out about AFP for a while. It's so cool. And it's really cool to watch too, because I don't think you can really get a sense of scale for it in the videos, but this thing is huge. It takes up a whole building.
No kidding.
Yeah, it's really cool.
It's just like mesmerizing, sort of. You just see the thing and it wraps and it wraps and it just like...
It's a big rotisserie chicken, just spins the barrel around and it can, go down this big track.
Yeah.
It's really cool. And the arm itself, it's like something that comes straight out of like Tony Stark's workshop. It's
nice.
Awesome.
And the whole point there is the automated machine. Sure, you can do it by hand. That's how you originally were making the barrels. But the automated machine is more precise. It can sort of repeat the same things over and over again as you ramp up that production cadence.
Exactly, yeah. So AFP, at least for Alpha, can make production up to 9 times faster and 7 times cheaper.
No kidding.
Yeah, so we're starting to really ramp up into a production cadence. We want our kind of artisan hand lay work to be done on the pieces that need it, and we can take some of the load off of our layup techs and have all the barrels and really big things just get made by AFP.
Right.
Yeah.
Like we mentioned yesterday, the AFP is a large machine that works in certain geometries and sizes, but there is still a need for hand layup.
Yes.
Folks actually making the more complicated structures or just geometries that don't work with a big automated machine.
Yeah, very much so.
Nope.
And oh yeah, there you
Look
go.
at that. So the vapors you see coming out the bottom of the engines there are the beginning of engine chill. You'll see those start to beef up. I don't know,
Beef
get
up?
more dense. I don't know.
They'll get more liquidy, I guess.
Liquidy, liquid up.
Less liquid up. Yeah, they'll be less gaseous and a little bit more kind of like proper liquid.
Yeah, just they look more like they're not dripping. It's like you can see drops almost, as opposed to just gas coming out like that.
Yeah, and I can explain that maybe a little bit later. Should I bring out the props?
We should. We have a couple minutes for the props, I think, right?
Minutes for the props.
Yeah, let's do the props. Y'all keep watching the rocket here. But
keep an eye.
part
Keep
of
an
the
eye,
whole carbon composite structures is testing them, right?
Yes.
You need to make sure that the different layers have adhered together. So
Yeah.
we once again have the forbidden ice cream sandwich.
I've brought back the ice cream sandwich, the Oreo. So yeah, kind of a quick rundown of how some of our structures work. This is what's called a sandwich laminate, fittingly enough. On the outer edges, the kind of like the cookies
Yep.
of the sandwich, you have a bunch of layers and layers and layers of carbon fiber. And that's your load path. So
Right.
these two outer sheets carry all the load that the barrel is seeing.
It's like the main structural support, I guess you could say.
Yeah, that's carrying everything. And then in the middle, sandwiched between the two cookies,
The ice cream.
is the ice cream, foam core. Yeah, so what this does, it's two-part, very important. One, it provides stiffness to the structure because it kind of makes this whole thing act like an I-beam rather
Right.
than just like a single solitary structure. And also it provides thermal shielding to our propellants. So for something like our cryogenic locks, very important because you've got negative 300 degree Fahrenheit cryogenic fluid inside the tank, and then you've got 70 degree, whatever degree.
Outdoor ambient fog, I guess, in Vandenberg.
Ambient fog in
Marine
Vandy.
layer.
So yeah, you want to make sure that you're not just instantly boiling off all of your propellant. So
Right.
this helps with that.
So it's both structure and insulation in the. I feel like we need to keep reminding people that it is the forbidden ice cream sandwich.
Please don't eat
You
this.
should not try to eat. That is not a thing. Yeah.
Crunchy, spicy. Your body's not going to like that.
Do not. Yeah.
Please don't. But yeah, and there's every once in a while there comes a point where you have to inspect the health of your structures.
Right.
We do this in a couple ways. I've tapped on this thing before. Tap testing is something that's not just in aerospace industry. You can find it, when you're laying tile. You
Right.
Tap test
So
to
you
make
have
sure.
a hollow bit under the tile that's going to break one day when you're coming out of the
Exactly.
shower or whatever.
If you hear that hollow thud, then there's a void underneath your tile, and there's no mortar there.
Right.
Same principle here. If you tap it and you hear a thud, there's a void in your laminate, and there's no resin filling.
You don't
that
get the
spot.
nice clear tap noise. You feel it as well because it's a
Yes.
piece of piano wire, you said, right?
Yes, this is piano wire on the handle, so not only can you hear if you have some kind of damage, but you can also kind of feel the resonance back through the handle, and you can kind of it's just kind of a second away of.
You hear it. It's like a tactile thing as well, I
Yes,
guess, right?
it is.
Nice.
And tap testing, I'm just going to go ahead and
Sure.
send it. So that's what it's supposed to sound like.
Sounds good.
It's supposed to sound super sharp and clear. If you were to kind of hear like a thunk,
Yeah.
that's what you don't want to hear.
Right.
This is one of the ways that we NDI our structures. There's another way that we NDI our structures, and that is ultrasonic testing.
Okay.
So not exactly one-to-one, but kind of like a pregnancy ultrasound. You take the goop.
There's goop. There's actual goop.
There is goop. We put goop on the rocket, and you take your ultrasonic probe.
A little wand.
Yeah, you have a wand.
Okay.
And you scan the structure. And what it's doing is it's sending sound waves from your probe into the structure, and it's measuring the time it takes for those sound waves to bounce off
bounce
something
back.
and come back.
Okay.
So you could detect, if it's going through your structure and, hitting the foam core and
Right.
coming back, that's a different time than if it would go through your structure, hit a void or disk-bond of air,
And then.
and come back.
Okay. So you're sitting there, you have the goop, you have the wand, you're like scanning it, and you're like, congratulations, it's an alpha.
It's an Alpha. It's a Carolox rocket.
It's a Carolox rocket. All right, we are under 12 minutes now, actually 10 and a half because we like talking about structures. One day we're going to have to bring some other structure testing stuff in here. People are going to be like, oh man, it's the tap thing again.
Yeah.
But let's talk really quickly about what is going to happen because things are going to start happening fast.
Sure. Yeah, so right now, so we're under the last 12 minutes of launch. So we've been doing a bunch of commands and health checks, over
Right.
300, including we've been chilling in our stage 1 engines. So kind of we talked about like that kind of gaseous thing you see on screen.
On screen right there.
Slowly getting more and more liquidy. That's us pulling cryofluid through our LOX pumps.
Right.
Cool them down to the temperatures that we need them to operate at for flight.
So that's just, you don't want to surprise the temperature. You want it to be a nice thermal gradient, I guess. You sort of bring them down over time to their operating temperature, as opposed to suddenly going from normal temperature to cryo temperature.
Yeah, if you pull in that 300-degree, cryogenic fluid onto a 70-degree pump, you're going to flash the gas. It's going to lead to cavitation and all that kind of grossness. Yeah. So we want to stay away from that. So we've been doing that since T-minus about 15 minutes.
Right.
They need some time to kind of chill in. We've also done some ground side prep, so TVC wiggles, TTEB, spin start verification, fuel pre-press, stage 2 TVC wiggles. There's just a whole line of things that we work through.
We've got all sorts of acronyms we're going through here, but at less than 10 minutes to launch, we better keep pressing ahead. Fuel pre-press is a thing that is going to start happening in about a minute, and we'll get some more TVC, the thrust vector control wiggles, just making sure everything is moving the way it should move. At some point, we'll transition to internal power as well, sort of unplugging the rocket from the ground, making sure that it's all healthy on its internal power, I guess not generation, batteries really, so that it's ready to go. And then we're going to see some larger things on screen, right?
Yes.
Like right there.
Yeah, so you'll start to see that strong back pull back. Well, first the collar arms will open. I hope the strong back doesn't pull back when the collar arms are closed.
Those are on the top. Oh, it's like right over here on the side.
Yes, so you can see them in that shot. Kind of those little cylindrical-looking things that are
the claw pinchers.
Holding, the crab pinchers that are holding on to that stage 2 LOX tank. Those will kind of separate and get wide, and then the whole tail will kind of pull back.
Out of the way of the flames of liftoff.
Yes, out of the way of the flames of liftoff. Not only that, but in the last couple minutes before flight, we'll actually arm our FTS, our flight termination system.
Yep.
Standard safety thing for all launch vehicles. And then we'll start our fuel bleed at T-minus 3 minutes, and then we'll be pretty much ready to go.
Pretty much ready to go. And now that we are coming up on 8 minutes to launch, let's talk about what happens after liftoff, or I guess starting 2 seconds before liftoff.
Yes, you're exactly right. So at T-minus 2 seconds, we have stage 1 ignition. So those 4 reavers will light. And we do this at T-minus 2 for 2 reasons. We do it to allow those engines to get up to their full nominal power. And we do it just to make sure that if there is something that we need to worry about, we catch it before we let the rocket go.
Right.
So we do that at T-minus 2 seconds. You'll see ignition. At T-minus 0, that is when we release the clamps and Alpha is allowed to lift off from the pad. We'll be flying for about 56 seconds until we go supersonic, and then we'll hit something called max Q at T plus 1 minute and 6 seconds. It's maximum aerodynamic pressure.
Right.
Yeah, I could ramble about max Q, but I've done it before.
If you want the full explanation on max Q, go to the stream from yesterday where we had a lot of time to talk.
Yes, as a structures person, I can ramble your ear off about why max Q is important. I'm not going to do it right now. But yeah, at T plus 2 minutes and 33 seconds, so a little over a minute after max Q, we'll have MECO, which is our nominal main engine cutoff. And then things start to happen really quickly back to back. You'll have MECO, and then you'll have nominal stage separation right after that.
Right.
Your first stage has kind of done its job getting you out of Earth's atmosphere.
Like up, away from the planet.
Up and away, yeah. And so we don't need it anymore. The fuel's spent. We don't need that mass.
No need to carry it.
No need to carry it with us. It's done its job. So we separate, and then we'll actually have our stage 2 lightning engine ignite, and you'll see stage 2 kind of start to pull away from a falling back stage 1.
Right.
And then same thing with the fairings. We'll have nominal fairing jettison at T plus nearly 3 minutes. And what that is the fairings have protected the payload with their ECS throughout,
all the way from the building.
Yeah, all the way from the building to the pad while it's sitting out there, vertical on the pad through the atmosphere. It's not needed anymore. There's nothing really in space that can harm the payloads. So we jettison those fairings so that, we don't need that mass either.
Don't need to carry them. That's a big part of being a rocket is don't carry mass that you don't need.
Yes.
It's why you do the carbon composite structures.
Exactly.
That's how you can have more room for propellant and payload. But shedding things that have done their job that you don't need to carry with you anymore is an entire thing with rockets.
Yeah, mass can be very expensive, so you want to cut it where you can.
Yep.
Yeah. So after we have fairing jettison, remember that lightning engine is still going, so we'll fire until T plus 8 minutes 28 seconds where we'll have SECO.
Right.
That is second engine cutoff. And then from there, we will just kind of coast until our nominal payload deploy area.
Yep.
Trajectory. And we will actually have a planned comms blackout during that time. So after SECO... Oh, there goes the strongback.
The clamps have opened, and the strongback is retracting. We did not see that yesterday.
We did see that yesterday. It is good to see. Yeah, you see those umbilicals kind of pulling tight. Those will not
Tudo indica que vamos ter lançamento, hein? 5 minutos. 5 minutos para o lançamento, aí suporte de apoio então do Alpha. sendo recuado. 10 horas 33 minutos pelo horário de Brasília. Estamos acompanhando então o voo 6 aí do Alpha da FireFly com a missão Message in a Booster.
And as it goes around the planet, it goes in and out of range of different ground station antennas. So here we do have that anticipated comms blackout that starts around 9 minutes after liftoff, and that's going to actually continue up until T plus 35 minutes. Now, even though we don't have live telemetry coming down from the rocket, since it doesn't have a ground station to talk to, the rocket is still recording everything that's going on.
Yeah.
But in that period, we expect the payload deployment to happen. And after we get back in range of a ground station, we'll downlink all that information. The first thing that we downlink is going to be the data telemetry, like the bits that come down describing the health of the vehicle and exactly what happened.
Yeah.
And then a video payload will come down, the recording of that payload deployment. But because we're not going to get that until T plus 95 minutes, specifically the video, almost an hour and a half after launch, we don't plan to stay live the entire time today. We are going to intentionally stop the broadcast a little bit after SECO there, just because we're going to run out of things to show you, except for Morgan and me.
Yeah, don't let me talk about structures too long. I'll spill some secret sauce on accident.
All right. So I think we're down to 3.5 minutes, and we are going to rapidly start coming up on the next go, no-go poll here, the sort of final go, no-go poll, aren't we?
Yep, you'll only be hearing 3 goes or no-goes.
Right.
Yeah, so it's kind of the last gate before we start to really get ready for launch.
Okay. I don't know if it's cleared up a little bit here, but we do see the rocket silhouetted on the pad. You can see the strong back has retracted a little bit, and we're going to come in to listen.
Chief Engineer.
Send it.
To the final commit.
Launch Director.
Launch directors go.
Rock.
Rock, range green.
We are go for launch.
There you go. All right, now 2 minutes and 40 seconds away from launch. The final commit, everything green. Once again, just bang, 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 right down the list. 3 folks checking in saying they are go for launch here for Alpha.
Yeah, that's about as nominal as you can hope for.
It's about as nominal as you can hope for. Excellent. Folks, here's the plan. Remember, we are going to show you all the views that we have here. We have some tracking cameras. It may be tough on the liftoff. This is really going to bloom when this thing takes off. But for now, we're going to let you listen in to the sounds of the pad. The pad and the rocket are really going to come alive here. Everything trending go. We've heard a bunch of goes, and they've just been going right down the list as we cross T-minus 2 minutes away. That means that we are ready to launch Message in a Booster. This is Flight 6 of FireFly's Alpha rocket at a very foggy Vandenberg Space Force Base this morning. Let's go ahead and listen into the pad, and we will check back in with you after liftoff.
Retard arm. Alex.
That's cool.
T-minus 1 minute.
Helium bubbler. Alarms off. Vehicles in autonomous mode.
Nominal stage 1 TVC motion.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Mission and liftoff from flight nominal Alpha go Alpha FLTA006.
Flight operators transition to ascent ops. Ground operators, please. Transition to ground. Channel frequency.
Vehicle supersonic. Max Q.
Man, you can see the atmosphere thinning.
You really can. That plume expansion there.
That's beautiful. Should be coming up on Miko here.
T plus 2
in about
minutes.
30 seconds.
God, the way that comes back together, it's literally the exhaust gases bouncing off the atmospheric pressure and then coming back together. Continuing to go down range here. Two and a half minutes after
Miko.
liftoff. Coming up on
Stage separation.
Miko.
Stage 2 ignition. Chamber pressure looks nominal.
Fairing separation.
Have a view from the vehicle here.
You can see the fairings jettisoned.
Yep.
Otherwise, you couldn't see the Earth.
The limb of the Earth in the background. Little bit of motion there. But now we're into that longer second stage burn. The lightning doing its job to get that horizontal velocity going around the Earth. And there is that aft-facing view in the background there where the rocket just took off from. Here you can see the booster is no longer behind the rocket. I don't think we can see it in this shot. I suddenly wonder if that little dot up there is it. But this is the second stage, looking backwards at the engine on the second stage. Looks like some of the trackers are having a little difficulty keeping it in frame there. It's really interesting how clear the exhaust is here. But once again, going to Stay with it. We are going to come up on an expected comms blackout. We're going to try to share with you the views here from the vehicle as long as we have them. The comms blackout is expected, but it's also a little estimated. So if the feed cuts out a few seconds before the exact timing that we were talking through, that might be nominal.
Yeah.
How you doing, Morgan?
I'm doing great. Sorry, I'm being handed things. And I can only focus on one thing at a time. Yeah, I'm doing great. That was a beautiful launch. And I just love watching these camera views.
Yeah. It was a little tough there with the marine layer. We had a lot of bloom on the ground. A little tough to see the rocket lifting off. I love that we kicked it off with the engine shot. Just kept it with the engine shot as they sort of exited that blast camera down in the trench itself, or I guess right under the engines. But Lightning and Stage 2 continuing on with the propulsion here.
Yeah, again, we're expecting to burn this engine until T plus 8 minutes and 28 seconds.
Right.
That's when we expect SECO.
So another 2.5 minutes roughly in this burn.
Yeah.
Yeah. And again here, this phase of flight is all about gaining velocity around the planet, right? First stage got us up out of the atmosphere. It got us sort of away from the ground a little bit. And here, we're basically flying sideways. See this question a lot, like, oh, why did the rocket turn sideways? And then look like, from my perspective, it was going back down to the water. Well, the Earth is round. It was going around the Earth, over the horizon. That's exactly what the Lightning engine is doing here, pushing that stage. And the payload... I like this. Look, we got both cameras.
Oh, nice.
On around the planet.
Yeah, orbit is basically just falling constantly and just missing.
Missing, yeah. Coming up on T plus 7 minutes. We're also listening into Mission Control now, so if any call-outs come from Mission Control, you will get them directly from there. That really is just a cool shot. Like you can even see, like it's headed south, and the sun was rising. To the, like if you were on the rocket, the west would have been the left-hand side of the rocket, and there you can see the Earth a little bit illuminated there, and then a little bit darker on the right-hand side.
You can see the sun reflecting off of the rocket itself.
Yep. But about 7.5 minutes, and coming up in just about a minute, we're expecting that SECO, second engine cutoff. Again, we may not have views all the way up to that. We will see. We're going to share the views with you as long as we have them. But let's see here in about another 30 seconds whether we get those views the entire time. And then remember, the payload deploy is not expected to be seen live here. The payload deploy isn't happening until a while after SECO.
Yes. So SECO happens again at about 8.5 minutes, coming up here in a couple seconds, and then we'll see our planned comms blackout a little after 9 minutes. Payload deploy will happen somewhere around, I think, 12.
Right. I'm watching the flicker of the second stage engine there.
A liberação da carga, conta do par da parte todo o período de comunicação.
And had the SECO call out
após o SECO
from Mission Control, and you could also see the engine shut down.
E tivemos então o SECO, né, desligamento então do estágio 2 confirmado. Vocês podem ver então na tela.
Expected LOS at VTRS in 60 seconds.
E aí vamos ter então o período de blackout.
And rapidly approaching that expected LOS, like we talked about before liftoff. Back in Mission Control, you can see everyone focused on their consoles. I think the call out was assessing data.
Oh, yeah. When I run tests and things, I wish I have more than 3 monitors. I usually see a bunch of flack for people having 3 monitors in the control room, but you're actually looking at a lot of data at once.
Right.
You've got the GUI on one, you've got, you know, all your plots on another, you've got cameras on another, and then sometimes I want a fourth for another another monitor full of data, because there's just so much to look at one time.
Right. Now coming up on T plus 10 minutes. We are going to have some replays for you coming up here of the liftoff cameras we didn't show live. And also we'll talk how you can keep up to date with the mission status here. So now's the time when we can ask, if you were out at home, did you step outside during liftoff, and were you able to see that? If you're over there in LA or San Diego, over in Phoenix, Arizona maybe, all the way over to Albuquerque, let us know in the chat, did you catch any information, did you catch any shots of that launch? And I think we just heard the LOS there. And tag us on social media if you did. All right. So, folks, that is the views that we are able to share, that we have, because we are now in that comms blackout. And as we discussed earlier, because of the long delay before we're expected to get that signal back, and then the priority order of downloading the data, getting the telemetry first, and then getting any video that's able to come down of payload deploy, that's not going to happen for almost another hour and 20 minutes. So we will not plan to stay live through that.
Então, devido ao longo período de comunicação, né, de blackout de comunicação com o veículo, né, infelizmente então vamos conseguir transmitir para vocês em loco até a liberação da carga, né, mas assim que tivermos atualizações, vocês acompanharão aí pela rede social ali no X, né, no meu canal, tá bom? E o PTV sempre mostrando tudo que acontece ao redor do mundo. Obrigado aí por assistir este lançamento aí. Mais um na conta. 10 horas e 49 minutos, 29 de abril de 2025. Muito obrigado, então, por assistir esta transmissão mais uma vez. Até a próxima.
All right. The big thing here is the data coming down, the team's reviewing the data that came down on the rocket. And I think our best possibility here is to start wrapping up and have y'all give you the good information on how to find on social media and on FireFly's website further mission updates. FireFly is going to provide an update on payload deployment within the next couple of hours. So stay tuned on X, the website, etc.